Okay, friends, being said this, I'm going to jump onto the tool portfolio of Altair Electromagnetic Solutions. And most of the folks about FEKO. FEKO doesn't need any introduction, and it has been in the market quite a long. And you can for your antenna design and placement analysis, most of the folks are using FEKO. Yes, it's not like the 2 to 3 years ago. The scenario is only we have FEKO or WinProp, but now we expanded our wings and we strengthened our EMAG portfolio to the maximum extent, and we keep on going to build the portfolio much more bigger. And you can see over here, you do see all the tools like Altair FEKO, high frequency electromagnetic simulations. And also you can see over here, MUFASANT, which is complementary to FEKO. I'll be talking about this particular slide as well in a couple of minutes. Then we do have Altair WinProp, where we can solve any wave propagation and radio network planning. And then WRAP, spectrum management and co-site interference. Okay, you can see over here. Let me tell a simple example over here, which I like most. In case if you wanted to solve any simple coverage issues at your home, you can play with your router and you can plug and play, and you can get the connectivity wherever you have got the dead zones. But it is not the same scenario if you are going to work with multi-state buildings and big scenarios. Then the situations are different. It's not that easy that you cannot plug and play as we are doing for a home scenario. There we need to use a tool, something like what we have over here, WinProp, definitely helps you to solve the problems. And WRAP, spectrum management and co-site interference. Yes, this is another tool which can help you to solve the problem for the spectrum management in a bigger way. Once we have reached the suburban and rural scenarios with WinProp, then you can go with the countries and provinces using WRAP. I'll be talking about that part as well. Then we do have one more latest acquisition, and on PCB analysis tool. From the electromagnetic standpoint, in case if you would like to solve any signal integrity or power integrity analysis, yes, definitely we can use the POLX for our EMAG problems. Okay, in a nutshell, you can see over here how the graphical FEKO launcher looks. Earlier, we used to have only FEKO and WinProp. Now that we do have MUFASANT and WRAP, everything is there in one particular bunch, and you can launch any of the applications to solve the antenna design modeling to the the coverage and radar coverage analysis and network planning applications. Okay, simple problems to any complex EM problem can be easily solved using the spectrum of tools that we got in Altair. Okay, in the Altair EMAG portfolio. And also you can see over here, you can find all the documentation for these tools in this particular launcher. Yes, even as I mentioned, when I joined, I used to have only FEKO and WinProp, but it is no longer the same. We strengthened our portfolio. And then let me jump on to the next slide. Okay, here I do have a Altair FEKO. Altair FEKO, let me first talk about this particular FEKO tool. Just introduction about that. Most of you folks are aware of FEKO tool. And we have broadest range of solver technologies that are available to solve the electromagnetic problem. Okay, you see over here, method of moments is there, FEM is there, FDTD is there. Similarly, we do have asymptotic solvers like PO and RLGO, and UTD is there. And also recently we added faceted UTD in the asymptotic solvers. Similarly, we added adaptive cross approximation solver in full wave methods. Apart from not only that, we do have a strongest MLFMM as well in the full wave methods where we can solve the problems. And also we can hybridize these solvers appropriately to solve your electrically large problems. Like assuming that you take an aircraft and you place an antenna, you would like to solve that kind of problems. Yes, that kind of problems can be easily solved using this spectrum of solvers or the solver technology over here. Any simple antenna can be designed, or complex model like an MRI application. You can see a human head over here on the right side. Yes, even that can be solved. You can see complex of materials with electrical size. Hybridization to solve large and complex problems. Yes, that is the strength of FEKO. Yes, so I can strongly say that this is the strongest, one of the biggest strong point of FEKO, where you can solve a wide range of problems using solver technologies in FEKO. Then, as I told you, your simple problems like antennas, you can see over here, and also array antennas can be easily solved. It is the frequencies you can see 110 megahertz to 1 gigahertz and also 1.62 gigahertz. Some of the radiation patterns and also the reflection coefficient and impedance parameters were shown in this particular problem. And also we used method of moments and MLFMM to solve this particular problem. And as I mentioned, this FEKO is very strong at solving the antenna placement problems using the technologies. And I took various platforms over here. I took a Jeep over here, and also as I mean to say automobile, just to cater the needs for automobile, and also aerospace. You can see aircraft and also a satellite, and also a naval application. It doesn't mean what application you are using, we can solve that particular problem. Yes, you can see the radiation patterns. Once we have a Jeep over here, automobile vehicle, where we kept our monopole antenna and we computed the radiation patterns at 150 megahertz. Similarly, we could also compute the 1 gigahertz using the solvers that are available in FEKO. Similarly, we solved the problem at 120 megahertz and also we solved the problem at 1 gigahertz on the aircraft application, where we kept the antenna on the aircraft. Similarly, for the naval application, we could able to, because you can see that a ship is sailing on a sea, and we solved for the radiation patterns and surface currents. Especially here, we solved for the surface currents. You can see we got it at 100 megahertz. Yeah. Also satellite, which is radiating at 1.6 2 gigahertz. Then let me jump on to the next. Yes, one more strong thing that we can do is that collocation interference analysis. You can do any co-site interference analysis. You can place many antennas on top of the aircraft, and you can compute the collocation interference. And we do have a nice interface between FEKO and WRAP, and we could able to solve that particular problem. Okay. Using very detailed report, you can get all the coupling values as parameters from FEKO, and you can take it and you can go to WRAP and you can get a nice collocation interference. Yes, you can see over here the wide variety of applications that can be accomplished using the FEKO software. Simple antenna design to antenna placement. That's what we have seen in the earlier slide. Then electromagnetic compatibility studies, scattering or radar cross section, and all the others. And we do have a wide variety of multi-physics analysis and optimization. And let me jump on to the next tool. Yeah, next tool that we do have over here, Altair Newfasant. Altair Newfasant is, you can see over here, Newfasant, which is complementing FEKO. As I mentioned, most of the solvers that are available in FEKO are available in Newfasant. And what is the additional advantage you are going to get? We do have some asymptotic solvers that are available in Newfasant, like GTD and hybridization of GTD. Among the hybridized solvers, there is a hybridization is possible. Among asymptotic solvers, that is possible as well in Newfasant. And you can see the problems like RCS and antenna placement, reflect arrays, radomes, including frequency selective surfaces. All these things can be solved. Apart from that, there are some additional applications as well. But for the plan of action or the roadmap for Newfasant is to take the solvers and integrate them into FEKO, so that the users don't need to learn additional GUI. That's the plan that is going to go, which we are planning ahead. But for now, the tool is available and all the materials and the information is available with you folks. Yes, in case if there is something interesting for you, definitely we can discuss. Please reach out to me. I can help you with that. And there is a webinar, there is a coffee break session on radomes, including frequency selective surfaces, radome design using Newfasant. I'll be talking on that one on I think it's on number 5 coffee break series. We'll be discussing there. Then WinProp. WinProp considers the large environment for antenna pattern computed in FEKO. As I told you, simple example, house example to rural or suburban scenarios. In case you want to perform the radar coverage analysis or any network planning, yes, the WinProp is the best bet. You can solve the indoor scenarios, suburban scenarios, or rural scenarios, urban scenarios. All these things can be solved using WinProp. You can also consider topography and clutters with individual buildings for rural or suburban scenarios in WinProp. And the computational methods you see over here, rate crossing solvers and dominant path model and empirical methods. You can see over here propagation models for various scenarios in WinProp. It might be topo data, yes, rural propagation, urban propagation, and indoor propagation. 3 different scenarios we took, and also the propagation models which we used to solve for the coverage analysis were shown over here. Yes, you can see 3D standard racing, 3D intelligent racing, 3D rate racing appropriately for rural propagation and urban propagation and indoor propagation. Okay. Okay, folks, you can get the model. You can get the map data from yes, different fashions. It might be a street map, or it might be USGS, etc. We have all the capabilities and nuts and bolts to address or to import those maps into WinProp. Yes, the applications you can see over here: radar coverage and radio channel modeling, deployment and optimization of radio networks, virtual drive tests for ADAS applications and antenna performance analysis, coexistence of radio networks, and electromagnetic exposure. Okay, these are all the WinProp applications that we'll be discussing about in the next couple of slides, but it can cater a wide variety of needs. Since it is the first day of the coffee break, I would like to take a little more time on this particular electromagnetic simulations. Just please bear with me 5 more minutes. Okay, folks. And we do have propagation models for various scenarios in WinProp. Yes, you can see over here: indoor scenario, urban scenario, rural scenario, and tunnel scenario. These are the coverage plots, and also a virtual drive test scenario, not virtual drive test, this is a drive scenario. Virtual drive test you can call. We can able to get all these particular things that done using WinProp. Some of the results that we obtained from WinProp. And virtual flight test, large scale terrain scenario, virtual flight and drive test in large scale topographical or clutter scenario, define 3D trajectory and aircraft orientation, yeah, pitch or roll. You can see over here, assuming that an aircraft is flying on the platform. It might be a city environment or rural environment or suburban environment. You can consider the flight path tagged with an antenna, and you can study the coverage analysis. Okay, you can define the 3D trajectory and aircraft orientation, and you can get the received power levels appropriately and coverage range along trajectory. We can use these propagation models to solve the problem, like Longley Rice and dominant path model. Okay, folks, not only that, we can also do the network planning using WinProp. Network planning on system level, including beam forming, envelope beam pattern with static load per cell, Monte Carlo simulation with individual beam assignment. Okay, we can get all the data rates and signal to noise ratio, noise ratios, as well as data throughputs. All these things can be applied using network planning. Okay, and we do have a very nice air interface files that are available preloaded. Also, if you want to have your own defined air interface for your network planning, yes, WinProp supports that one particular thing as well. Yes, we are done with suburban rural scenarios, but in case if you want to study for the coverage analysis for a bigger scenario like provinces and countries, yes, we do have one more tool in the Altair WRAP portfolio. What is that called is WRAP. WRAP, you can see simulations at the level of provinces and countries, terrain and clutter maps, usually no individual buildings, wide range of methods, menu ITU models. Yes, as I told you, we can do the radar and radar coverage and spectrum management at a very bigger level using WRAP. Large scale radio and radar coverage, and also collocation interference, satellite communications. You can see the pics over here, how we can able to get the 3D plots for antenna placement for a big scenario or a coverage over a province or a country scenario. Okay, and also we could able to include the jammers to study the radar coverage analysis inside WRAP. And this is the satellite communication, of course. You can also perform that one. It supports many ITU models are there to support this kind of analysis over here internally. Okay, you can see all the ITU models. And not only that particular thing, we do have attenuation due to atmospheric gases can be included for terrestrial, and you see ITU.R.P.2.2108 and building penetration layers can be added. There are a lot of ITU models that were supported in WRAP, apart from the standard COS 231 valve Fishikigami, Okumura Hota, and Longley Rice models. Okay, these are the propagation models that supports to solve the problems to get the coverage analysis. One can use these particular things appropriately based on the needs. Yes, simple. Yes, radar coverage, radio optical visibility with user-defined target, and also you can see jammers can be included in analysis. That's what I was talking about. We can get the coverage for the spectrum of for the country or province, and you can include the jammers, and you can study the coverage analysis appropriately. You can also clutter can be included appropriately based on your analysis, and you can see the color scheme that shows about the radar coverage for 1 meter square, 10 meter square, and 100 meter square appropriately. So just in a nutshell, connection between these three tools, FEKO for FEKO, WinProp, and WRAP, how they are connected, FEKO for antenna design and placement, and WinProp for radio channel simulation, urban and indoor simulation, to very big areas, radio and radar channel, radar coverage, and spectral management over countries. And last but not least, the POLEX, which is, as I was telling you about, POLEX is very good for signal integrity and power integrity analysis. In case if you have any PCB that you would like to work with the signal integrity and power integrity analysis, yes, POLEX can be your go-to tool to solve those problems. Apart from that, we do have verification tools like electrical and manufacturing tools. This goes for, of course, for mechanical engineers. For us, I strongly recommend in case if you want to do any signal integrity and power integrity, please go ahead and use POLEX. Then we do have partner alliance tool, which you can go ahead and you can choose that. Especially there are a lot of tools for the partner alliance, 150 plus software products were there, and you can see over here the microwave wizard, where it is very good for passive components. In case if you would like to design any passive components, it is very easy. The GUI part is very easy. It got library of components that are available. You can just drag and drop into GUI and connect them. If you are designing any feeder or power dividers or something like that, yes, the inbuilt algorithms can solve the problems in no time. The computational time is really advantage when you are solving the passive devices using microwave wizard. Yes, folks, this is about the summary of the Altair FEKO tools. Thank you for your attention. And this is again Dr. Raja Devata, and my email ID is ddevata@altair.com. In case if you have any questions, we will touch base. Please reach out to me. Don't hesitate to reach out to me.